What can change things from being all real numbers? Who remembers? Vivek?
Denominator.
Good. We cannot have a denominator of 0. Now, in a normal scenario, if there's no variable in the denominator, if there's just real numbers in that denominator, can it be 0? No, it can't be 0 if there's no variable there. But the minute there's a variable in the denominator, now there's an opportunity that we have an undefined expression. So that affects the domain. All right. What's the other thing that can affect the domain? Lily? An imaginary number. And what would create an imaginary number? Ariana? Good, a square root of a negative number. So if I have a variable under a square root sign, that again now has the potential of creating an imaginary number. So those are the two things. And if those two things don't exist, if I don't have a variable in the denominator, if I don't have a variable under a square root, then what is it safe to assume that my domain is? All real numbers. All right, the other thing is finding the zeros of a function. Now, when we find the zeros of a function, we're saying what input would I put in for x? What input would I put in for x that would give me an output of 0, right? Because the zero of a function, get this out, the zero of a function is where our graph crosses the x-axis. And what happens where we cross the x-axis? All of the points for y are 0, right? All the points for y are 0. So we're saying what input of x would give me an output of 0? That's what's happening. So what do we do to find the zeros of a function? We take our function and set it equal to 0 and solve for x. So that's where we had left off yesterday. Let's do some problems. Okay, so I want us to find the domain and zeros of each function. So the first one's going to be f of x is equal to x squared plus x minus 2 and x times x minus 3. So you tell me, is there going to be a restriction on the domain? Absolutely. How do we know there will be a restriction on the domain? Good. There's a variable in the denominator. So now how do we find this restriction on the domain? What we're going to do is we take the denominator. So for domain, take denominator, set equal to 0, and solve. So we have x times the quantity of x minus 3 equals 0. Well, luckily for us, this has already been factored. So now all I'm going to do is set each factor equal to 0. So the denominator will be 0 when x equals 0, or when x equals what? 3. So the denominator will be 0 if x is 0, or the denominator will be 0 if x equals 3. So what is our domain? Our domain is going to be, and all you have to do for domain, you're going to write domain, and you're just going to say x cannot equal 0 or 3. And that implies that every other number is okay. That implies that as long as x is not 0, x is not 3, every other real number is okay, and I would accept it just like this. You don't have to write anything else. Okay, the next part is finding the zeros. So what I'm going to do is to find the zero, I need what input for x will give me an output of 0. So I'm going to take my whole function and set it equal to 0. And then we solve for x. Well, to solve for x, won't I cross multiply here? And what's 0 times anything? 0. So now we're going to have x squared plus x minus 2 equals 0. X squared plus x minus 2 equals 0. Can I try to factor this? Yeah, and we can factor it. It's going to be an x plus 2 and x minus 1 equals 0. So we're going to get x equals negative 2, x equals 1. Now, after I solve and find the 0, is there anything I should check? You think? Is there anything I should check? There is. There's something I should check once I find my zeros. Any guesses, Amanda? You got it. So what I want, once I find my x's, I want to go back to the domain. And I want to make sure the x that makes my function a 0 is not an x that will make my function undefined. Does that make sense? So you want to double check that. So I get what will make my function a 0, x equals negative 2, or x equals 1. Does that overlap with something that's not allowed in the domain? No, so we're okay. Let's say it did overlap with something that's not allowed in the domain. What should we do in that scenario if you had to guess? Ariana? Yeah, exactly. We would regard it as an extraneous solution. We would be like, you know what? This is not part of my answer. It can't be part of the domain. If it's not part of the domain, it can't be part of my solution. So we would sort of just reject it at that point. All right. So now we have the two zeros. We have x equals negative 2 or 1. All right, you guys try this next one. So same thing, I want you to find the domains and the domain and the zeros. You guys recognize what happened?
I don't know. Do you have to show? Do you have to say the name of the equation? No, you don't say. You just have to show the setup. Yeah, I did that.
Okay, let's go over this. So again, I wanted us to find the domain and the zeros. Where's my stylus? So the domain, there's two things we're looking that can affect the domain. First thing is a variable in the denominator. Second thing is a variable underneath a radical. In this scenario, what do we have? A variable in the denominator. So we need to make sure that denominator does not equal 0. So what do? We say, okay, well, what happens or when will x squared minus 2x equal 0? Or we could, if you want to remember that it can't equal 0, we could put it cannot equal 0. So we can pull out that x, GCF of x. So then we have x minus 2. When will x times the quantity of x minus 2 equal 0? It will equal 0 when x is equal to 0 or x is equal to positive 2. So our domain is going to be any real number except 0 or 2. Okay, next part is the zeros. So when will we have a 0? When will our graph cross the x-axis? What value of x will give us an output of 0? Well, we won't know. We're going to take our function and say we need an output of 0. Set it equal to 0. Treat this like a proportion and cross multiply. So we're going to get x squared minus 5x plus 6 equals 0. And then we factor. So we're going to have an x minus 3 and an x minus 2 equals 0. And then we solve. So we're going to get x is equal to 3 or x is equal to positive 2. So those are the values that I would input for x to get an output of 0. But what is it that we should check? Are these values of x within our domain? So let's go back to our domain. Our domain was restricted. Our domain was saying x can be any number except 0 or 2. Is this a problem? Yes. So is x equal to 2 a 0 for us? No, x equal 2 is not a 0. We're going to reject. And we're only going to have x equals 3 as a 0. Let me show you what this would look like in Desmos, just so you can see. I think I lost it. Okay, here it is. Okay, so we said that we had a 0 at 3 right there. And then it said we had a 0, well, we thought we might have potentially had a 0 at x equals 2. 1, 2. Well, let's show that. Okay. That's wrong. Was that it? Was it x equals, we had x equals 0.
Like if you trace your cursor along it, it'll show like the undefined circle. I saw it. Go to the
No,
like
there's,
on the red one.
no, I know, no, but that's not a 0, but x can't equal 2 at all. Where is, oh, I see what you're saying, but usually it just shows automatically, I thought. Yeah, I'm trying. It should say that, but it's not.
You're on the blue.
Oh, that's why. Okay, let's go. Try this again. Oh, there we go. That's what I wanted. Okay, so we said x could never equal 2. Right there. If you show this, if you look at this and it doesn't show, thank you, Charlie, until you hover over it. Right there. It's hard to hold steady, but that is an open circle. What does that open circle mean? It's not included in our graph, right? That is undefined there. So we have that open circle there. And obviously the other one was x equals 0. Nothing, if you notice, the graph gets really, really close to 0, but never crosses, right? Ariana. Okay, so I see what you're saying. When you're finding the domain, you want to find it before you cross anything out. So you always find the domain before you factor and like simplify, if that makes sense. For zeros, you can do it after it's factored, absolutely. Because then that would have just eliminated that extraneous solution for you. Okay, let's keep going. So the last thing we're going to do today, we are going to talk about composite functions. So let's say I gave you two functions. F of x is equal to 3x plus 2, and g of x is equal to 3x. First question for you, unrelated to what we're actually doing, but just rolling in. For f of x or g of x, are either of our domains restricted? Good. No restricted domain. What does that mean if there's no restricted domain? Then what is our domain? All real numbers. Very good. So for both of these, we do not have a restricted domain. This is not part of what I'm doing now. Just wanted to show you what that would look like. So now let's say I ask us to find f of 2. What this is telling us, or what this is asking us, not telling us, what this is asking us by me asking find f of 2, it is saying, let my input for x be 2, tell me what the output is. So remember in Algebra 1, we're like, oh, this is a function machine, right? So what does this mean? Anytime, so it says find f of 2. So I go to the function f of x, not g of x, because it says f of 2. So I go to my f of x function and I input the 2 where I see x, and I simplify to find what my output would be. So here, if I'm finding f of 2 is going to be 3 times 2 plus 2. So f of 2 is going to be 3 times 2 is 6 plus 2 is 8. What does this mean? Like on a graph, what would this mean? Somebody besides Ariana, what would this mean on a graph? Vivek? Good. If we were to graph f of x, the point 2 comma 8 would be on that graph. That's what this is mean. It means there would be a point where x is 2, y would be 8. All right, next one. Okay, so now what is this saying? I'm asking you to find g of 2. So it's saying go to which function, f of x or g of x? G of x. And I'm going to input a 2 for x. So wherever I see an x, I'm inputting a 2. So g of 2 is going to be 3 times 2. So g of 2 is 6. What does this mean? What does this mean on a graph? Leo? There is a point 2 comma 6. Let's go to Desmos. All right, so let's go to the point. Right here. All right, there's the point 2 comma 6 on our graph. All right, next one. Let's find f of g of 2. So think of PEMDAS, guys. When there's multiple parentheses, which ones do you work with first? What do we work with first? Charlie? The innermost parenthesis first, not any difference here. So we have f of g of 2. So we're going to work with the innermost parenthesis first. Well, what's the innermost parenthesis? G of 2. So that means go to g of x and plug in a 2 for x. So we already did that. What was g of 2? 6. So now I have f of 6 because g of 2 gave us 6. Now what I have is f of 6. So now I go to the f of x function, and wherever I see an x, what am I inputting? A 6. So it's going to be f of 6 is equal to 3 times 6 plus 2. So f of 6 is 20. Again, what does this mean? On the graph f of x, the point 6 comma 20 exists on that graph. All right, you guys do this one. Actually, I'll do this one with you. You could do the next one by yourself. So if I have f of g of x, is there a number to input? There's no number to input. It's saying f of g of x. It's not saying f of g of 1 or f of g of negative 10. It's saying f of g of x. So what does this mean? It means I'm going to g of x. What expression represents g of x? 3x. So now g of x is 3x. I'm now going to go to f of x, and wherever I see an x, I'm now going to plug in 3x. Exactly. So f of g of x is going to be f of 3x. That's what f of g of x is. So now I go to the f of x function, and I'm going to say, okay, well, f of 3x is going to be 3 times 3x plus 2. So f of 3x is 9x plus 2. Okay, you guys do this last one. G of f of x. Well, this is not the last one. Sorry, you guys do this next one. Diana? For what number am I looking at? So can we write f of g of 2? Yeah, absolutely. Either one is fine. So now this is saying f of x is 3x plus 2. Now we're finding g of f of x. So I'm finding g of 3x plus 2. So I'm going to go to our g of x function, and wherever I find an x in my g of x function, I'm plugging in a 3x plus 2. So g of 3x plus 2 is going to give us 9x plus 6. How many people got that? Perfect. Okay, now something we should know. We can perform all operations with functions. What does that mean? Let's say I told you f of x is equal to 2x minus 3 and g of x is equal to x squared minus 2. I want us to evaluate g of -1 minus f of -2. Okay, so what does this want us to do? It wants me to go to g of x, and wherever I see x, what am I subbing in? -1. So I could do this in my head. The quantity of -1 squared is 1, minus 2 is a -3. So g of -1 is -3 minus, now we're finding f of -2. So, Ariana? Oh, sorry, not -3, -1. Thank you. All right, and now we're finding f of -2. We're going to plug in this -2 for x in f of x. So 2 times -2 is a -4. -4 minus 3 is a -7. So I have -1 minus a -7. Well, doesn't this double negative make a positive? So I have -1 plus 7, which is 6. Let's say I have g of c plus f. Sorry, c plus h. Sorry, g of c plus h minus g of c all over h. Okay, so now I'm going to first substitute in. So this is saying g of c plus h. So I'm going to g of x, and wherever I see an x, what am I substituting instead of x? C plus h. So this is going to be, here's our g of x. Do we agree this is going to be c plus h quantity squared minus 2? That's g of c plus h. Anybody confused with how I got that? Violet? Okay. So, see g of x is x squared minus 2. And then it's saying g of c plus h. So they're saying go to the function g of x. And wherever you see an x, what am I substituting instead of x? C plus h. But this x is quantity squared, right? So now this is going to be c plus h quantity squared, but we still have that minus 2. Better? Okay. But then it's saying minus, so this whole thing came from this. Now it's minus g of c. So again, I'm still going back to g of x, but this time I'm going back to g of x, but wherever I see an x, I'm subbing in a c. So now it's going to be minus parentheses c squared minus 2. Do I need those parentheses there? I do. Why do I need those parentheses there? Yeah, because I'm subtracting that whole quantity, so I need that. All over h. Is this c of f of h or g of h? No, so it's just h. There's nothing to plug into because it's not g of h or f of h. It's just h. So now we have to simplify that numerator. What do you think I have to do to simplify that numerator? You got it. We're going to FOIL the quantity of c plus h squared, which is going to give us c squared plus 2ch plus h squared. We still have that minus 2. And then we're going to distribute the negative. So minus c squared plus 2 all over h. We good with that? Now let's look for our like terms. So I have a c squared and a negative c squared. What happens there? They cancel right out. I have a negative 2 and a positive 2. What happens there? They cancel right out. So now I am left with 2ch plus h squared all over h. Is that my final answer? Good. Why is this not my final answer? Violet. You can pull out a GCF of h. So we have 2c plus h over h. Those h's cancel. So we end up with 2c plus h. All right, you guys try this next one on your own. What does that be? So we're using the same f of x, g of x. So f of x is 2x minus 3. G of x is x squared minus 2. Okay, so if we're going to evaluate g of f of a, I'm starting off with my innermost parenthesis, which is f of a. What is this telling us to do? This is saying go to f of x, and wherever I see an x, what should I sub in instead of x? An a. So this is going to be g of 2a minus 3. Everybody good with that? Now it's saying g of 2a minus 3. So now I'm going to g of x, and wherever I see an x, now instead of the x, what am I subbing in? 2a minus 3. So this is going to be 2a minus 3 quantity squared minus 2. Do I need to FOIL and combine my like terms? Absolutely. If I FOIL this, I'm going to get 4a squared minus 12a plus 9, and then we still have that minus 2. So this becomes 4a squared minus 12a plus 7. How many people got that? Okay. All right, last one for today. So if f of x is equal to 2x plus 1, I want us to evaluate f of 2. Okay, so remember, when there's multiple parentheses, don't we work with our innermost parenthesis first? So we start with f of 2. So what does this mean? I'm going to take that 2. I'm going to sub it in for x in f of x. So I could do this in my head. 2 times 2 is 4 plus 1 is 5. So f of 2 is 5. So now I have f of 5, because this f of 2 all became 5. Are we good so far with how I got that 5 and how I wrote it like this still? Okay, so now, again, I'm working with my innermost parenthesis. So now this is saying f of 5. So I go to f of x, wherever I see an x, I sub in a 5. 2 times 5 is 10 plus 1 is 11. So now this whole f of 5, no more f there, right, becomes 11. Last time, f of 11. So now I'm going to go to f of x. Wherever I see an x, I'm now going to sub in an 11. 2 times 11 is 22 plus 1 is 23. All right, we are done for today. You do have